Hello guys, welcome back for a question from the chapter in integral functions, and let us see what do we have as our integrand. So we have 1 upon 1 minus 10x as integrand, and we need to integrate this function with respect to x. Now if we see the question, it looks pretty easy that we have only 1 upon 1 minus 10x, but this question is not that easy. This question is bit slight complicated. We need to make some changes to the original functions so that we can make it integrable. So let me first give you a hint. I hope you all have solved this standard question, that is sin x minus cos x over sin x plus cos x. This is a standard question given in the NCERT book. So we somehow have to transform this original function to this standard question so that we can integrate it further. So how do we do that? The first step I can imagine is that we have to write 10x as sin x upon cos x. So that is what we are gonna do here. So they have done the same thing. They have substituted 10x by sin x by cos x. Now further simplifying the expression, we have cos x upon cos x minus sin x. Now what is our next step? Our next step is to multiply 2 in the numerator and 2 in the denominator. You must be thinking that how did we get that idea? There is no picture perfect formula to get the idea that where we have to multiply 2 or 3 or what. It just comes naturally by the practice. So when you practice many questions, you will automatically get the idea that where we have to make a substitution, or where we have to assume that this part cos x minus sin x will be treated as t, or where we have to multiply a constant. So this all comes naturally by the practice. So that's too much of TED talk. Now let us move to the next slide. So we had 2 cos x minus sin x in the uh, what did we had? 2 sin x minus cos x? I don't remember. So we had something in the numerator multiplied by 2. So if we expand that part, we get cos x minus sin x plus sin x. And in the denominator, we have cos x minus sin x. Now this part becomes 1 plus we get a separate part here. So this part is easily integrable now. The integration of 1 is x. Now we are gonna solve this part. You can see that now we have reached our point where I told you that we have to get that standard form, cos x plus sin x upon cos x minus sin x, the similar one. So now we can easily solve this part. What we do, we assume cos x minus sin x as t and then differentiate it on the both sides with respect to x. So what do we get? We get minus sin x minus cos x into dx is equal to dt. So we make both the substitutions, this one and this one here, and we get a final integrand that looks like this. Now this is very easy integration. Integration of 1 by t with respect to t is log modulus t. Now moving to the next step. In the previous step slide, we saw that we get a final answer as t, but we need to remember that we have to back substitute the value of t. That is, we have to write our final answer in the terms of the variables that we were given with. We were given the function in the variable of x, so we need to make the final substitution as x only. So our final answer is x by 2 minus half multiplied by log of cos x minus sin x plus an arbitrary constant h c. So that is it. I hope you all got it. Thank you. Have a nice day.